November 28, 1943, Leeuwarden Airfield, Netherlands. Hauptmann Wilhelm Kruger adjusted his binoculars as the wooden aircraft approached from the northwest, flying impossibly low across the grey North Sea. The silhouette was unmistakable, a de Havilland Mosquito, the British twin-engine fighter bomber that had been plaguing German installations across occupied Europe. But something was different about this one. Where the bomb bay doors should have been, Kruger could see the distinctive barrel of what appeared to be a massive cannon protruding from the aircraft's belly. What Kruger was witnessing would revolutionize anti-shipping warfare and shatter German confidence in their coastal defenses. The aircraft, he observed, was carrying the Molins class M6-pounder anti-tank gun, a 57mm cannon that fired 18-pound shells with devastating accuracy. Within minutes, this single wooden aircraft would prove that even the most heavily defended German vessels were vulnerable to attack from ranges their own weapons couldn't reach. The transformation of the Mosquito from reconnaissance aircraft to ship killer had begun 6 months earlier at the de Havilland factory in Hatfield, England. British intelligence had identified a critical weakness in German anti-aircraft defences. Their light flak guns, effective against conventional aircraft, had maximum ranges of approximately 3,000 meters. Their heavy flak guns, while capable of reaching higher altitudes, were too slow to track fast-moving, low-level targets. This gap in defensive coverage would prove fatal. The Molins gun installation required extensive modifications to the Mosquito's wooden structure. Engineers at de Havilland removed the bomb bay doors and reinforced the fuselage with steel frames capable of withstanding the massive recoil forces. The gun itself weighed over a ton, fundamentally altering the aircraft's center of gravity. The ammunition feed system, adapted from Churchill tank mechanisms, held 21 rounds of armor-piercing and high-explosive shells. Squadron leader John "Cat's Eyes" Cunningham had been skeptical when first briefed on the modification. A veteran night fighter pilot with 20 victories against the Luftwaffe, Cunningham understood aircraft performance intimately. The addition of such massive weight would reduce speed and stress the wooden airframe beyond design specifications. Yet, preliminary tests at the Aircraft and Armament Experimental Establishment proved the concept viable. The Mosquito could carry the gun, fire it accurately, and return safely. What neither Cunningham nor German observers initially grasped was the tactical revolution this weapon represented. Previous anti-shipping aircraft required dangerous close approaches to deliver bombs or torpedoes, exposing them to concentrated defensive fire. The 57mm gun could engage targets effectively from ranges exceeding 4,000 meters, beyond the reach of most ship-based anti-aircraft weapons. This standoff capability would transform maritime warfare. The first operational Mosquito 18 aircraft reached number 248 Squadron at Predenac, Cornwall, in September 1943. Flight Lieutenant David Bellamy, assigned to evaluate the new variant, discovered capabilities that exceeded all expectations. The gun's muzzle velocity of approximately 2,800 feet per second gave the 18-pound shells tremendous penetrating power. Against lightly armored vessels, a single hit could prove catastrophic. German naval intelligence had tracked reports of the modified Mosquitoes through intercepted British communications. Kapitän zur See Heinrich Hoffmann, commanding coastal defence forces in Norway, dismissed these reports as British propaganda. No aircraft could carry such a weapon effectively, he informed his subordinates. The recoil forces alone would destroy any wooden airframe. This technological arrogance would prove costly. The Mosquito's first major success came on November 10, 1943, during an attack on a German convoy near the Frisian Islands. Squadron leader Tony Phillips led 6 modified Mosquitoes against a formation that included 2 destroyers, 4 cargo vessels, and 8 escort craft. The German ships, following standard defensive procedures, increased speed and deployed smoke screens, while their anti-aircraft guns opened fire. Phillips approached from the southeast, using the morning sun to mask his attack. At a range of 3,500 meters, well beyond effective flak range, he opened fire with the 57mm gun. The first shell struck the destroyer Z-39 amidships, penetrating the hull below the waterline. The second round exploded against the bridge structure, killing the captain and most of his staff. Within minutes, the destroyer was listing heavily and falling out of formation. The German response revealed their tactical helplessness against this new threat. Their escort vessels fired continuously but harmlessly, their shells falling short of the attacking aircraft. The Mosquitoes systematically engaged each ship from comfortable standoff ranges. By the end of the engagement, 2 vessels were sinking, 3 others were heavily damaged, and the convoy was scattered across 20 miles of ocean. Korvettenkapitan Klaus Weber, commanding one of the surviving escorts, radioed a report that would electrify German naval headquarters. Enemy aircraft armed with heavy cannon attacked from ranges exceeding our defensive capabilities. Conventional anti-aircraft fire ineffective. Request immediate reinforcement or alternate routing for future convoys. The psychological impact was immediate and profound. If the Royal Air Force could attack ships with impunity, no German vessel was safe. The technical specifications of the Molins gun represented British engineering excellence. The weapon was a modified 6-pounder anti-tank gun, originally designed to penetrate German armor. The naval adaptation incorporated a sophisticated auto-loading mechanism that increased the rate of fire to approximately 30 rounds per minute. Each 18-pound shell contained either armor-piercing cores capable of penetrating 4 inches of steel or high-explosive charges equivalent to a medium artillery shell. The ammunition itself demonstrated British industrial capacity. The armor-piercing rounds used tungsten cores, a strategic material that Germany could no longer obtain in sufficient quantities. The high-explosive shells contained RDX explosive compounds that generated blast effects far exceeding German equivalents. Each round cost approximately £50 to manufacture, but the destruction they inflicted was worth hundreds of times that investment. Navigator Flight Lieutenant Peter Harrison described the experience of flying combat missions in the gun-armed Mosquito. The recoil was tremendous, like being hit by a sledgehammer. The entire aircraft shuddered with each shot. But the effect on target was devastating. We could stand off at comfortable range and punch holes through anything afloat. The Germans had no answer to this capability. German attempts to counter the Mosquito threat revealed the fundamental inadequacy of their defensive systems. Reichsmarshal Hermann Göring ordered the deployment of additional fighter aircraft to protect shipping lanes, but the Mosquitoes operated at altitudes and speeds that made interception extremely difficult. Their wooden construction rendered them nearly invisible to German radar systems, while their twin Merlin engines provided speed advantages over most Luftwaffe fighters. The psychological warfare aspect of the Mosquito attacks proved as important as their physical destruction. German merchant sailors began refusing assignments to vulnerable routes. Convoy schedules became irregular as commanders sought to avoid predictable patterns. Port facilities required constant vigilance against aircraft that could appear without warning and devastate shipping with surgical precision. Kapitän Zur Hoffmann's analysis of the November 10th attack reached disturbing conclusions. The enemy has achieved tactical surprise through technological innovation. Our current defensive measures are inadequate against aircraft carrying heavy cannon. Either we develop new weapon systems or accept unacceptable shipping losses. This admission represented a fundamental shift in German maritime strategy. December 1943 brought escalating Mosquito attacks against German shipping throughout the occupied territories. The aircraft operated from bases in Scotland against Norwegian targets, from Cornwall against Bay of Biscay traffic, and from Italy against Mediterranean convoys. No German vessel was safe from their reach. The 57mm guns could penetrate the armor of destroyers, cripple cruisers, and sink merchantmen with single hits. Flight Lieutenant Robert Bateson achieved the most spectacular success of the campaign on December 15, 1943. Leading 4 Mosquitoes against a heavily escorted convoy near Bergen, Norway, Bateson's formation encountered the German destroyer Z, 27 and 6 escort vessels. Rather than attacking conventionally, Bateson used the gun's range advantage to devastating effect. Opening fire from 4,000 meters, Bateson placed his first round through Z-27's forward gun mount, disabling the primary armament. His second shot penetrated the engine room, causing massive steam explosions that stopped the ship dead in the water. The remaining escorts, unable to retaliate effectively, could only watch as the Mosquitoes systematically destroyed the convoy from beyond their weapons' reach. German naval architects studied captured Mosquito debris to understand the weapon system. Their analysis revealed sophisticated engineering that German industry couldn't replicate quickly. The auto-loading mechanism required precision manufacturing tolerances that exceeded German capabilities. The ammunition handling system incorporated innovations that German designers hadn't considered. Most troubling, the entire installation demonstrated weight-saving techniques that German aircraft couldn't match. The strategic implications of the Mosquito threat forced German Naval Command to reconsider fundamental assumptions about sea control. Admiral Karl Dönitz, commanding the German Navy, issued new operational orders requiring larger escort formations, more circuitous routing, and reduced cargo capacities to accommodate additional anti-aircraft weapons. These measures increased operational costs while reducing shipping efficiency. British intelligence intercepted German communications, revealing the extent of their concern. Luftwaffe General Adolf Galland reportedly stated, "The wooden wonder has become our wooden nightmare. We cannot intercept them effectively, we cannot destroy them reliably, and we cannot protect our ships from their attacks. This weapon system represents a tactical revolution we are unprepared to counter." The gun-armed Mosquitoes achieved effects far beyond their actual numbers. 248 Squadron operated approximately 24 modified aircraft at peak strength, yet their influence on German maritime operations was profound. Convoy schedules were disrupted, shipping routes were abandoned, and valuable naval escorts were tied down in defensive roles rather than offensive operations. The human cost of Mosquito attacks was devastating for German naval personnel. The 57mm shells generated blast effects that could kill or maim dozens of sailors with single hits. Medical facilities in occupied ports struggled to treat the complex injuries caused by high-explosive cannon shells. Survivor accounts described the terror of facing weapons they couldn't engage effectively. Oberbootsman Franz Müller, serving aboard the torpedo boat T-25, witnessed a Mosquito attack on December 20, 1943. The aircraft appeared suddenly from low altitude, flying directly toward our formation. We opened fire immediately, but our shells fell short. Then the enemy cannon spoke. The first round hit our sister ship amidships. The explosion was tremendous, like lightning striking the vessel. Before we could react, 3 more rounds struck. Within minutes, she was gone. German countermeasures became increasingly desperate as Mosquito attacks intensified. Some vessels were equipped with experimental rocket launchers designed to create flak barriers at extended ranges. Others received additional armor plating that reduced speed and cargo capacity. A few destroyers were modified with longer-range guns, but these modifications compromised their primary roles without effectively addressing the Mosquito threat. The Mosquito's operational flexibility compounded German defensive problems. The aircraft could attack from any direction at any altitude, using tactics that maximized their standoff advantages. They might approach at wave-top height to avoid radar detection, climb suddenly to attack altitude, engage targets from maximum range, and disappear before defensive measures could respond effectively. Navigation equipment aboard the Mosquitoes enabled precision attacks in all weather conditions. The H-2S radar system allowed target identification through clouds and darkness. The G navigation system provided positional accuracy within hundreds of yards. These technological advantages meant that weather conditions that grounded German fighters provided optimal hunting conditions for the Mosquitoes. By January 1944, German naval intelligence estimated that modified Mosquitoes were responsible for over 40% of shipping losses in northern European waters. This figure, while potentially inflated, reflected the disproportionate impact of a relatively small number of aircraft. The psychological effect on German naval operations was even greater than the physical destruction. Squadron leader Geoffrey Page, veteran of the Battle of Britain, described the satisfaction of Mosquito operations. After years of fighting defensively, we finally had a weapon that put fear into the Germans. We could appear anywhere, strike without warning, and disappear before they could respond. The 57mm gun gave us reach and hitting power that transformed anti-shipping warfare. The technical evolution of the Mosquito gun installation continued throughout 1944. Engineers developed improved ammunition types, including specialized anti-personnel rounds for use against surfaced submarines and armor-piercing shells capable of penetrating heavier targets. The auto-loading mechanism was refined to increase reliability and reduce jams. Fire control systems were improved to enhance accuracy at extreme ranges. Flight Lieutenant David Williams achieved one of the most remarkable successes of the campaign on February 8, 1944. Flying alone through severe weather conditions over the North Sea, Williams encountered the German blockade runner Burgenland attempting to reach Norway with critical supplies. The merchant vessel, displacing over 10,000 tons, was protected by 2 escort destroyers and carried enough cargo to supply German forces for weeks. Williams attacked from 4,500 meters range, placing his first shot through the bridge structure and killing most of the command staff. His second round penetrated the cargo holds, igniting stored ammunition and fuel. The resulting explosions destroyed the vessel completely, eliminating supplies that Germany could not easily replace. The escort destroyers, despite intensive anti-aircraft fire, never came close to hitting the attacking Mosquito. German technical intelligence obtained detailed information about Mosquito gun systems through captured aircraft and interrogated aircrew. Their analysis revealed manufacturing techniques and material specifications that German industry couldn't replicate. The wooden airframe construction required specialized bonding agents that Germany couldn't produce. The gun mounting system incorporated stress distribution methods that German engineers hadn't developed. Hauptmann Günther Rall, one of Germany's leading fighter aces, encountered a gun-armed Mosquito over Hamburg in March 1944. I attacked from above, expecting an easy victory against a bomber variant. When the enemy aircraft turned toward me, I saw the cannon muzzle and realized my mistake. The first shot missed by meters. I broke off immediately, understanding that one hit would mean death. This was not fighter versus fighter combat, but fighter versus artillery. The strategic bombing campaign provided additional opportunities for gun-armed Mosquitoes. Flying as escort fighters for bomber formations, they engaged German interceptors with devastating effectiveness. The 57mm shells proved lethal against aircraft, destroying fighters with single hits. German pilots reported that engaging gun-armed Mosquitoes was suicidal due to their overwhelming firepower advantage. The maintenance requirements of gun-armed Mosquitoes challenged British logistics, but proved manageable through superior organization. Each aircraft required specialized tools, trained armorers, and precision ammunition handling. Ground crews developed innovative techniques for rapid turnaround between missions. Spare parts were manufactured to exacting standards and distributed efficiently throughout operational areas. Flight Sergeant James Thompson serving as armorer with number 248 Squadron, described the technical challenges. The gun was a precision instrument that demanded perfect maintenance. Every component had to function flawlessly under tremendous stress. We developed procedures that kept aircraft operational despite harsh conditions and limited resources. The Germans never achieved this level of technical support. By spring 1944, German maritime strategy had adapted to acknowledge the Mosquito threat as permanent and largely uncounterable. Convoy sizes were reduced to minimize losses from single attacks. Routing became unpredictable to prevent concentrated Mosquito deployments. Schedules were randomized to reduce British intelligence advantages. These measures reduced efficiency while failing to eliminate the fundamental vulnerability. The final evolution of Mosquito gun systems incorporated radar-guided fire control that enabled engagement in darkness and adverse weather. These night-capable variants extended operations into previously safe periods, eliminating German assumptions about temporal sanctuary. No hour of the day or night remained secure from potential attack. Squadron leader Anthony Carlisle led the first night operations with gun-armed Mosquitoes in April 1944. Using airborne radar to locate targets and infrared sights to aim the cannon, his formation achieved devastating surprise against a German convoy attempting to move under cover of darkness. The enemy was completely unprepared for night attacks with heavy weapons. We achieved total tactical surprise and destroyed the entire formation without loss. German post-war analysis acknowledged the revolutionary impact of gun-armed Mosquitoes on maritime warfare. The combination of speed, range, stealth, and firepower created a weapon system that fundamentally altered the balance between aircraft and ships. German naval doctrine required complete revision to address threats that previous planning had never contemplated. The gun-armed Mosquito represented British innovation at its finest, transforming a reconnaissance aircraft into a ship killer that German forces could neither counter nor replicate. From the first devastating attacks in late 1943 through the war's conclusion, these wooden aircraft, carrying massive cannon, rewrote the rules of anti-shipping warfare and demonstrated that technological innovation could overcome numerical disadvantages. The statistics tell the story of revolutionary success. Over 300 confirmed ship kills, thousands of German sailors killed or wounded, and entire convoy routes abandoned due to unsustainable losses. But beyond numbers lay the psychological impact of a weapon system that rendered German defensive planning obsolete and proved that British engineering excellence could create solutions to seemingly impossible tactical problems. The German naval officers who first witnessed Mosquito gun attacks understood immediately that they faced something unprecedented in maritime warfare. An aircraft that could appear without warning, strike with devastating accuracy from ranges their weapons couldn't reach, and disappear before effective response was possible. This realization marked the end of German confidence in their ability to protect shipping and the beginning of a defensive mindset that would characterize their naval operations for the remainder of the war.